As we continue looking at our special triangles, go ahead and draw another 30, 60, 90 right triangle on your paper. And this time we're not going to write 30 degrees, 60 degrees, because I'm too lazy for that. So instead, I'm going to put a single arc marking on this angle, and I'm going to put twice as many arcs on this one, indicating 30, 60, and of course the right angle marking for 90. So this is generally how you'll see this displayed on paper, just because I'm lazy. And let's suppose that we knew that this side was 6 inches. Again, the first thing you want to do, label the sides with the x's and stuff. Which side is the x? The side across from the 30-degree angle, the little leg, is the x. The hypotenuse here across from the right angle is always labeled 2x. But what I want you to do is, as you write it, since you were given 6 inches, go ahead and say 6 inches equals 2x. That way you see they are the same thing. This side is 2x. This side is 6 inches. They are the same. They are equal. And then this long leg across from the 60-degree angle, it's not twice as big. Twice as big an angle, yes. Not twice as big a side, rather x times the square root of 3. The key in every one of these, if you're not given the x, and again, the last two examples, the side we were given was x. Here it's not. We need to find x. If 6 inches equals 2x, then x must be, yes, 3 inches. So Kendall, if this side is x, then this side must be, 3 inches. Exactly right, because x is 3 inches, this side is x, this side is 3 inches. This side is x times the square root of 3, which means this side is 3 times the square root of 3 inches. And there are the other two sides. Again, the strength of the special triangle. Given one side, you have the ability to find two other sides. Pythagorean Theorem, the idea is, given two sides, find the third. C squared equals a squared plus b squared. What makes this a special triangle is you only have to know one side, and then you can find the other two very quickly and easily. Let's do another 45, 45, 90, but we're not going to write 45 and 45 for the acute angles. Rather, I'm just going to make a single arc mark on each, showing equality of angles, which means since they are complementary, the two acute angles of a right triangle, they must each be 45 since they're both complementary and equal. Let's suppose we know that the hypotenuse, again, like last time, is 6 inches. Again, the first thing we have to do, label the sides. Both legs get to be x, remember, but the hypotenuse will be x times the square root of 2. And again, say that it equals x times the square root of 2, because now we can clearly see, just as here, divide away the 2, and I get x is 3 inches. So here, I'm not dividing away a 2, but rather I'm dividing away the square root of 2. And that will give me that x is 6 over the square root of 2 inches. Well, this is kind of an awkward way to write my answer, isn't it? In fact, if you go back in your mind to algebra class, you know that you can't leave a radical in the denominator. That's not permitted. So what we would have to do here is rationalize the denominator. Make it a regular number. Take the square root of 2. Well, you can't. It's irrational. Well, you can't take the square root of 2, but you could take, for instance, the square root of 4. And you could make a square root of 4 if you'd multiply by the square root of 2, right? Square root of 2 times square root of 2 equals square root of 4. But what you do to the bottom, you gotta do to the top. So we're also gonna multiply the top by the square root of 2. Don't make this hard. What is 6 times the square root of 2? 6 times the square root of 2. One's rational, one's irrational. They don't mix together, they just keep them both. But I can now take the square root of 4, which is 2, and I can even reduce a little bit here. Now, you can't always reduce, but here I can, because the 6 and 2 are both rational. I can divide them to get 3 times the square root of 2. Again, don't try to divide the irrational square root of 2 by a rational 2. But the rational 6 does divide by the rational 2 to give a rational 3 times the square root of 2 inches. And this is correct, but written wrong. This is fully correct. That's x. Okay, I've gotten one side. How do I get this side? Well, it's x. X is 3 times the square root of 2 inches. So what is this? Yep, 3 times the square root of 2 inches. And there's our answer. Pretty straightforward there, once we go through the trouble of getting this. Similar thing will happen. We draw another 30, 60, 90, right triangle. Then mark your 60 with 2 arcs, and the 30 with 1 marking. Let's suppose I know that the long leg is 6 inches. Again, you've got to label your sides with the X's and stuff. Which side is plain old X? Besides cheating and looking over there, yes. The short leg across from the 30. The long leg across from the 60 would be not 2x, x times the square root of 3. The hypotenuse would be 2x. Remember, this came from an equilateral triangle. It's half of it. Every side has to be the same. So if this is x, then over here we'd also get x, which would make the whole thing 2x, 2x, 2x. So if that helps you to remember from whence this 30, 60, 90 cometh. It cometh from an equilateral triangle. But like last time, I'm given x squared of 3 is 6 inches. So to get the x by itself, got to divide away. Yeah, not 3, but the square root of 3. And that'll give me that x is 6 over the square root of 3 inches. Problem, just as you can't leave x over the square root of 2, you can't leave x over the square root of 3. What do I do to rationalize the denominator? You can't take the square root of 3, but you can take the square root of 9. If you were to multiply top and bottom by the square root of 3, this would now give me 6 times the square root of 3 inches over the square root of 9. A little bit of algebra review going on here, right? Of course, we know the square root of 9 is just 3. So it's really 6 times the square root of 3 inches over 3. And once again, it won't always work out, but it does here. I can reduce. 6 divided by 3 is? Yeah, 2. So I get 2 times the square root of 3 inches. Well, if that's x, how do I get 2x? Multiply that by 2. And 2 times the square root of 3 inches times 2 would be? Careful. Not 4 times the square root of 6. 4 times the square root of 3. Remember, this is a rational 2. It can multiply by this rational 2 to give a 4. Rational 2 does not multiply by irrational square root of 3. So 4 times the square root of 3 inches would be my answer. All right, for homework this evening, I'm going to have you do a handout that is not part of the larger set of handouts that was set up at the beginning of the semester. It's a standalone handout. It's in the description. It'll give you 5 of these special triangles. You'll be given it one side, find the other 2. If necessary, as you work it, watch this video lesson. So if you want to re-watch the video lesson, especially the ending portion, and say, okay, this is what I did here. This is what I do now. That's perfectly fine if that helps you to follow through. Now the numbers will be different, okay? But the process would be the same and could be of benefit to you. We'll continue practicing with this in our next lesson. You are dismissed.